Hi everyone! Today I'm going to discuss GPS tracking and how it relates to wildlife conservation efforts with the help of Tawe by Sparkol. So what is GPS tracking? GPS tracking, or the Global Positioning System, uses satellites to send signals to a GPS receiver on Earth to give its precise location. So how does GPS do this? There are at least 24 GPS satellites orbiting the Earth, which all make a full rotation around the globe every 12 hours. When you log onto your Google Maps app, the 4 closest satellites to you send the signal to your phone. The time it takes for the satellite signals to reach your phone is then used to calculate how far away the satellites were from you, which gives you your exact location on Earth. So how is this accomplished? Well, get ready for a little bit of physics. Take the equation distance equals velocity times time. The signal from the satellite moves with a velocity at the speed of light, which is around 3.0 times 10 to the 8th meters per second. The satellite also sends the time it took for the signal to reach the GPS receiver thanks to incredibly accurate atomic clocks on board the satellite. If these clocks are off by just 1 millisecond, then your GPS location could be off by 186 miles. After simply plugging those two numbers into the equation above, you get distance between you and one satellite. The distances from 4 satellites are then plugged into much harder equations, which we will not go over here, and voila! You now have a precise 3-dimensional location, which includes your latitude, longitude, and altitude in that exact moment in time. So how does GPS tracking apply to conservation? We are probably most familiar with researchers using GPS collars to monitor animal behavior and movement patterns. They have been used on a multitude of species, especially the ones most particular to my heart, the big cats. Hauser, Summers, and Bose 2009 fitted cheetahs with GPS collars in Botswana to learn the average size of male and female home ranges. After almost 4 years of tracking, researchers learned that males had home ranges between 494 and 663 kilometers squared, and a coalition of 2 males had a home range of a whopping 849 kilometers squared. Females had much smaller home ranges and were between 241 and 306 kilometers squared. This information was very important because before this research was conducted, almost no travel information was available for cheetahs in Botswana, and understanding how an animal moves throughout the land is vitally important for making informed conservation decisions. So what are the pros and cons of GPS tracking? As with most things in science, there are some drawbacks of GPS tracking just as there are benefits. As was found by Brooks, Bonyongo, and Harris 2008, the terrain, vegetation, and canopy cover surrounding an animal equipped with a GPS collar can affect the ability of the collar to connect with GPS satellites, thereby creating inaccurate location data. The weight of the collar can also significantly alter an animal's normal behavior, which creates obvious problems with data collection. Brooks, Bonyongo, and Harris 2008 also found that a very slight increase in collar weight from 0.4% total body mass to 0.6% total body mass reduced zebra foraging behavior by over 50%. So not only can GPS tracking with collars give inaccurate location, they can also inhibit natural behaviors. On the other hand, the benefits of GPS tracking are stupendous. Equipping an animal with a GPS device allows scientists to track and record animal behaviors remotely without any interference. GPS tracking can also be used as a supplemental information method. For example, Pittman et al. 2013 used GPS cluster analysis to find leopard kill sites, and then used fecal analysis to estimate the size kill the leopard consumed. Having a leopard tracked remotely saved the scientists several hours of searching on the ground for leopard fecal matter, thereby making the study much more efficient and with a lot more data than that they would have been able to collect otherwise. To conclude, I wanted to add a screenshot of what a GPS tracking map looks like. In this photo by movebank.org, you can see the movement of leopard F1 across Africa from 2001 to 2004. The green areas are protected land areas, and the leopard appears to have preferred these locations. This is wonderful to see because it means that the leopard was avoiding human-dominated areas and reducing the risk for conflicts with humans. You can log onto the website yourself and check out all different kinds of species from around the world and how they moved. It is incredibly interesting. Go check it out. I hope you enjoyed this presentation on GPS tracking, and thank you for watching.